like this, you couldn't have something like 1, 2, 3 and say that's a polygon. It has to be closed, whether it's a triangle with 3 sides or whether it's a quadrilateral with 4 sides, but it has to be a closed figure, and the sides have to be segments. So a circle is not a polygon because it doesn't have sides per se. So if you'll get your cutout, we're going to run through some of the arithmetic as we go through it. They're trying to get you to come up with a formula as you do we're actually looking for how many degrees are inside of each of these polygons. Now, they quit drawing pictures because the pictures get pretty crazy when you got down here, and it's kind of interesting the way that they go about it. We know that a triangle has 3 sides. Now, what did I write on there? Number of sides. Oh, and angles. So I put a slash and then I put an angle. I couldn't tell what my little, so that helps too. We know that a triangle has 3 angles and 3 sides. Now they drew an equilateral one. It doesn't necessarily have to be, they just did. Now when they say how many triangles do you have, that doesn't really make sense, but it is 1. And we know that the number of degrees inside of a triangle is 180 degrees. Now I'm going to write it this way for a reason, because we're trying to come up with what's going to happen as we add things to it, like when a quadrilateral. And so what they're saying when they say that a quadrilateral we know has 4 sides, okay, any 4-sided figure, squares, rectangles, even the figure I drew a while ago is a quadrilateral. So when they say how many triangles can you draw, they're saying take a vertex and draw across to the other vertices. And so in this case, if you draw to this one, it's a side. So you draw this one, they call it a diagonal. And so you've made 2 triangles. Now we know this triangle right here has 180 degrees in it. We know this one has 180 degrees. And so we ended up with 2 times 180, which is 360 degrees. And then as you go down the list, in a pentagon, which has 5 sides, and hopefully you know these names, if you start at any vertex and start drawing to the vertices, there's only 3 triangles that are formed. Let's see, sides is 5, number of triangles is 3. Now what they're trying to do is get you to figure out the relationship between these 2 numbers, and then the relationship between this number and this one, and that's what they want you to be able to do. So a 5-sided figure has 3 triangles, and you have 180, 180, 180, which is 3 times 180 degrees, which is 540 degrees. And then they go to a hexagon, which has 6 sides. There's 1, 2, 3, 4 triangles. Now, it's easy to see the numbers going this way, but we want to see them going across. And then, so you have 180 4 times, which I believe is 720. Yeah. Now they quit drawing them when they got to the heptagon, and that's not one we do very often, but that's a 7-sided figure. Now, what is the relationship? Where does this number right here coming from related to this one? Do you see it? It's not focused very well, is it? Do you see if we can get it to focus a little bit better? What do I do to 3 to get to 1? 4 to 2, 5 to 3, 6 to 4. What am I doing to those numbers? Yeah, what's this one going to be here? No, I agree with that, but what if you don't know the ones above it? So how are you going this way? Subtracting 2. Minus 2 will give me 5. And then I think you're seeing the relationship that it'll be 5 times 180, which I believe that one is 900. And then an octagon is going to be 8. The number of triangles will be 6. And 6 times 180 is 1,080. 1,080. I said it right first. 1080. And a nonagon is a 9. You might not have known that one. I'm going to give you a couple down here after we glue it in. And then that's going to be 7. 7 times 180 is what is that? 1260, 1260. Now, yes, as you look at it, you can see that you're adding 180 because you're adding another triangle, because these numbers, as you see, but normally you're not given the whole pattern. And then decagon is a 10-sided, and so the number of triangles would be 8. 8 times 180 is 1440 degrees. And let's go ahead and glue that in, because I want to do 2 more. Oh, we should have got, we can kind of freehand it. As you can see, it's not worth going up there and getting a geometer for that. I just realized, I see one thing we should have gotten one for. Okay, we're going to add to our list. Oh, you still gluing? The first one mainly because I just want you to know the name. Now, you can Google, what's a 20-sided, what's a 30-sided. I don't know a lot of the names, really, above a decagon. Those I know, and I think you should be familiar with. I don't use them, but here's what you would see on classwork and quiz. It might say something about a nonagon, so you want to know that that's 9. I don't know that they're going to mention this one, but I'm going to give it to you. It's dodecagon. Do you know that one? It has, definitely not going to draw a picture. It has 12 sides. So the triangles would be 10, and then it would be 10 times 180, which is 1,800 degrees. So then the ultimate is, and they don't call it an x-gon, they call it an n-gon, is what is the formula for an n-gon? 20-gon, 30-gon, 32-gon, 53-gon. What would be the formula all the way down? Well, here's the first one. We want to know, we're just not drawing pictures, and we couldn't draw an n-gon anyway because we don't know what that is. And I sure don't want to draw a 24-gon or anything like that. So, how many sides does it have? Well, nonagon has 9. Quadrilateral has 4. So an n-gon would have how many sides? If it's a 52-gon, it's going to have 52 sides, right? If it's a 12-gon, so it has n. So whatever n is here, it's going to have here. And a lot of times we just call them 52-gon. It'll just say 52-gon. And we can even do one if we need to. So then what's this number going to be? How are these two numbers related? N minus 2. And then what's this number? How many total degrees, the sum of all the angles inside? Well, you take your number of triangles, which is n minus 2, and I'm going to put that in parentheses because it is a binomial, and you multiply it by 180. Now, you can distribute that, but we don't actually learn it that way. We actually learn it this way because it makes it for an easier formula. So let me see if I'm going to do one that has different sides to it. I was trying to say if I had one that has, there's one that's a 27-gon. We'll do one on the Post-its. So we'll save that one in minutes. So whether you realize it or not, you just wrote the formula for the total number. Let's see, we'll just say total degrees in any, I think I just put in quotes, I'm going to say n-gon, whether it's a decagon, whether it's a pentagon, whether it's a 50-gon, is always equals n minus 2 times 180. Now, I usually put the 180 at the front just because we like to distribute from the front, but you can actually distribute from the back. But I'm going to write it 180 times n minus 2. I just like that better. It just doesn't look very focused to me. Maybe that's better. Okay, lots of definitions today because we're really, I guess you could classify it as starting a new chapter. That would probably be the best way to say it. Now my question is, do you know what a regular polygon is? Okay, I'm going to let you write this, and I am going to go get you the geometer for you. Okay, a regular polygon is what we like, and that one's regular. This one's not. I don't know about that one. Probably not. I'm not sure that one is by the way they drew them up here at the top. Definitely that one. I mean, just eyeballing it. No, I'm not sure those are. All sides, the same, and all angles, and I'm going to abbreviate angles, the same.